Welcome. In this tutorial, we will learn about how to connect and configure potentiometric linear displacement sensors with a data acquisition system. Let's get started. Step 1. Locate and review the manufacturer's datasheet for your specific potentiometric linear displacement sensor. Before making any electrical connections, it's important to note key parameters, namely, the physical measurement stroke, the available output options, and the required supply voltage. For this specific tutorial, we'll be working with a 0 to 10 volt analog output model, which needs 15 to 30 volts DC excitation. Step 2. Map out the sensor's wire color codes and their functions. Looking at the schematic on the right, the pinout layout remains consistent across output variations. Brown wire. This is the positive power input, or excitation plus. Depending on your setup, it connects either to the positive terminal of an external power supply or directly to the DAQ's EXC plus pin. Blue wire. This serves as the 0 volt ground return, or excitation minus, connecting to either the negative power supply terminal or the DAQ's EXC minus pin. Yellow wire. This carries the analog signal output, sending real-time measurement data straight to the DAQ analog input channel. Together, the brown and blue wires power the sensor, while the yellow wire feeds the measurement signal into your acquisition system. Step 3. Review the DAQ connector pinout configuration. Refer to your DAQ hardware manual to verify the correct pin locations for an analog voltage input. Examining the schematic on the right, our primary objective is to locate the measurement signal lines. Pin 7 maps to signal plus. Pin 8 maps to signal minus. As an alternative, if you choose to power the sensor directly from the DAQ module, you would use pin 2 for excitation plus and pin 1 for excitation minus. However, because our integration strategy uses a dedicated external power supply for this tutorial, these onboard DAQ excitation pins will remain unused. Step 4. Wiring the analog voltage configuration. Make the wiring connections as shown in the diagram on the right. First, connect the sensor's brown wire to the positive terminal of the external power supply, and the blue wire to the negative terminal. Next, route the sensor's yellow output wire to the DAQ cable's white wire, which maps to pin 7 as signal plus. Finally, take the DAQ cable's red wire, which maps to pin 8 as signal minus, and jumper it directly to both the power supply negative and the sensor's blue wire, to complete the signal reference loop. Now that the physical wiring is complete, Step 5 is to initialize the DAQ hardware and software. Align and firmly plug the wired terminal connector into an available input channel slot on the DAQ module. Power on the DAQ mainframe and launch the data acquisition software on your workstation. Verify the communication link, ensuring that the software detects the hardware and establishes a stable communication link with the module. Now let's switch over to the software interface to configure our draw wire sensor. First, navigate to the Sensor Database tab. In the database tree, right-click on the standard DC voltage 10V sensor template and select Duplicate Sensor. This creates a new customizable sensor profile. Select the newly created entry at the bottom of the list to open its parameters. Under General Information, rename the sensor, let's say Draw Wire Transducer, and the channel name as Channel_10. Next, move down to Transducer Settings. Since the sensor is powered by an external supply, set the excitation voltage to 0 volt. Under Conversion Settings, change the physical unit from volts to millimeters. Set the conversion range from 0 millimeters to 500 millimeters to match our draw wire's total displacement span. Check the linear scaling curve generated in the bottom right plot, mapping 0 to 10 volts directly to 0 to 500 millimeters. Click Apply to save this sensor configuration into the database. Now, switch to the Active tab to view the real-time display window. On the right meter display, perform a zero balance if needed. Your sensor is now properly configured for live displacement recordings during test. If this quick guide helps you get set up, hit the like button and subscribe for more instrumentation and testing tutorials.